Hello, my young and talented physicists. Welcome to class. In our last class, we discussed experimental verification of specific heat capacity, its significance, and we also looked at some calculation-related questions. In our class today, we shall be considering latent heat, as well as specific latent heat of fusion. I remain your host, AJAYI Sunday, AINA. Are you aware that heating a substance does not always increase its temperature? If heat is supplied to a block of ice at 0 degrees Celsius, it melts, that is, it changes its state and becomes water at the same temperature, which is 0 degrees Celsius. A thermometer dipped in the melting ice does not show an increase in temperature, despite the fact that heat energy is being supplied to it. The heat supplied to the ice during the process of melting is called latent or hidden heat. So let's look at some of the learning outcomes in our class today. By the end of the lesson, you will be able to 1. Explain the meaning of latent heat, 2. Distinguish between latent heat of fusion and specific latent heat of fusion, 3. Differentiate between melting and freezing points of a substance, 4. Solve simple problems using Q equals MLF. And the 5th one is explain regelation principle, while the last on the list is explain 2 factors affecting points of a substance. So let's start by explaining latent heat. Latent heat is defined as the heat absorbed or given out by a substance during a change of state at constant temperature, while specific latent heat of fusion is the quantity of heat required to change a unit mass of the substance at its melting point to a liquid without a corresponding change in temperature. Mathematically, you have your L subscript F, which is your specific latent heat of fusion, to be equal to Q divided by mass. And from there, you can derive your SI unit to be joules per kilogram. Let's take a good look at this picture. Look at this ice at minus 20 degrees Celsius. As it melts, there will still be some element of ice as it melts to 0 degrees Celsius. Then, from this point, it melts again as we withdraw heat from it to water, still maintaining the same temperature. Now, you can see Q equals MLF. This is where we say that there's a change of state from solid to liquid, but without a corresponding change in temperature. You can see that the temperature is still at 0 degrees Celsius, while at this point, there's a change in temperature from minus 20 degrees Celsius to 0 degrees Celsius. Here we have MC change in theta because there's a change in temperature. But from this stage to this stage, the same temperature has been maintained. So that is why we said without any corresponding change in temperature, even though there's a state, even though there's a change in states So latent heat of fusion is the quantity of heat energy required to change any given mass of a solid to liquid at a constant temperature. Now, having considered the latent heat, let's now look at the concept of melting and freezing point of a substance. Melting and freezing point of a substance. The melting point of a substance is the constant temperature at which it changes from solid to liquid. Ice melts at a constant temperature of 0 degrees Celsius. The heat supplied during the change of state is not registered by a thermometer, and that is why it is called latent heat of fusion. Freezing point of a substance. This is the constant temperature at which a substance changes states from liquid to solid. So it will become frozen as it moves from liquid states to solid states. Now, what are the factors affecting melting point of a substance? The melting point of a substance, of a pure substance, can be changed in two different ways. The first one is by adding impurities, and the second one is by changing the pressure applied on it. Impurities, the first one. Impurities alters the melting point of a substance. Addition of salt to a liquid at its boiling point or to ice will lower its melting point. Instead of ice melting at 0 degrees Celsius, it will melt at a temperature lower than 0 degrees Celsius. So the degree of lowering of the melting point depends on the concentration of the impurity added. So when salt is added to water in the ratio of 1 to 10, it will lower the freezing or melting point of that water to about -6 degrees Celsius. In cold countries, methyl alcohol and glycerin are mixed with water in car radiators to prevent it from freezing. This is because they lower the freezing point of water. And the second one is when pressure is being altered on the melting point and freezing point of a substance. The melting point of a substance is altered if the pressure on it is changed. For substances which expand on freezing or they contract on melting, their melting point is lowered if the pressure on them is increased. Ice, for example, expand on freezing, therefore its melting point is less than 0 degrees Celsius when pressure on it is increased. Then we're going to, having discussed the melting and freezing points, it is time to examine the effect of pressure on melting and freezing points. And this will lead us to a concept known as regelation principle. Now, what are the effects of pressure on freezing and melting points? An increase in pressure lowers the freezing point of water or the melting point of ice. When ice is subjected to a high pressure, it melts. But when this pressure is removed, from this diagram, the ice refreezes in a process called regelation. So what that means is that regelation is the phenomenon of melting under pressure and freezing again when the pressure is reduced. When two dry ice cubes are pressed together or they are stuck together, at their faces of contact, the melting point is reduced, making a film of water to form at the interface. As the pressure is removed, the film of water refreezes, sticking the ice cubes together. High pressures exerted by shoes or ice skates reduce the melting point and consequently melt the ice, forming a slippery layer of water. Now, another aspect is the pressure cooker. The pressure cooker uses the principle of increasing pressure inside the cooking chamber to raise the boiling point of the liquid in the cooker above its normal boiling point. At this high temperature, the cooking time is drastically reduced, hence it saves so much fuel. Let's look at some examples. Determine the quantity of heat required to melt completely 100 grams of ice initially at -3 degrees Celsius. Given that the specific heat capacity of ice is 2.20 times 10 raised to the power 3 joules per kilogram per Kelvin, while the specific latent heat of fusion of ice is 2.26 times 10 raised to the power 6 joules per kilogram. What are the parameters given? The mass of the ice is given to be 100 grams, which we need to convert to kilogram. So when that is divided by 1000, you get 0.1 kilogram. The initial temperature is -3 degrees Celsius, while the final temperature, θ2, is 0 degrees Celsius. So using the formula, Q equals mc change in theta plus ml subscript f. Then let's substitute our values. 0.1 times 2.20 times 10 to the power 3, then times 0 minus -3. Minus times minus will give us plus, then plus 0.1 times 2.26 times 10 to the power 6. That is the specific latent heat of fusion of ice. So by the time we multiply those values out, we shall end up having 226,660 joules as the quantity of heat required to melt completely 100 grams of ice, which is at -3 degrees Celsius. Let's look at the second example. An electrical heater of 2 kilowatts is used to heat 0.5 kilograms of water in a kettle of heat capacity 400 joules per Kelvin. The initial water temperature is 20 degrees Celsius. Neglecting heat losses, calculate the time taken by the water to boil. Given that specific heat capacity of water is 4.2 times 10 to the power 3 joules per kilogram per Kelvin, then the specific latent heat of vaporization is 2 times 10 to the power 3 joules per kilogram per Kelvin. So we shouldn't forget our usual concept that heat lost by the heater equals heat gained by water plus heat gained by the kettle. So since it has to do with electrical source, PT equals MC change in theta plus MC change in theta. And by the time we substitute all the values, the variables, non-variables given in the question, 2 kilowatts is still the same thing as 2000 watts when it is converted. Then substitute other values into the formula. Then the time taken will be 100 seconds. Let's look at some self-assessment exercises. The first one is define latent heat. Number 2, define specific latent heat of fusion. Then number 3, explain the regulation principle. You can ponder on all these questions as we draw of our class for today. In conclusion, the air conditioner, like the refrigerator, works on the principle that evaporation produces cooling. Warm air is drawn into the cooling units where it gives off latent heat to evaporate the refrigerant in the coiled pipe. I want to believe more knowledge has been added to what we've learned in our previous classes. I want you to keep a date with me and ensure you remain focused. Thank you and God bless you. Bye for now.